So now let's get ready to deploy our video processing service, and we're going to start by containerizing it with Docker. Now, instead of going over the entire Docker background, I'm going to focus on showing you how to actually use it, because this isn't like a Docker course, but I will kind of tell you and explain to you everything you need to know for the purposes of this project, and maybe even a little bit more than that. But at a high level, Docker solves the problem of taking the exact same code that is working currently on our machine. This code is working, but maybe we run this code on a different machine and it doesn't work. And the question we would have then is, well, why the hell not? Why isn't it working? And the answer could be almost anything, but usually it's related to the dependencies and the environment in which this code is running. And with Docker, we can precisely control that. We can package the dependencies. In our case, we know that before we even ran this code, we had to install Node.js. We had to install FFmpeg, and we had to do that on our machine. Not just this package, but we had to actually install the real CLI library. And if we try running this code without installing FFmpeg, it's not going to work. So that's where Docker comes in, and that's where containers come in. And in this video, we're specifically just going to be running Docker locally, but shortly after, we're going to deploy our container to Google Cloud Run, which is specifically designed for containerized apps. Okay, but now enough talking. Let's get started. Within our video processing service, we're going to create a file, not within the source directory. Let me click that. So we're going to create a Docker file. This is sort of the blueprint for our Docker image. And just to save time, I'm going to mainly be copy and pasting into this file. But for you, I highly recommend typing everything out, because that'll help you kind of understand exactly what's going on and help you remember things as well. The first thing you do with a Docker file is you start with a base image. In our case, we're starting with the Node 18 runtime, and it's a little bit misleading because this is not only including Node.js, but it's also built on top of a Linux Docker image. So Docker is kind of like running an operating system. And yes, Docker images can be built on top of each other. So we're starting with this Node 18 base image, which is itself built on top of a Linux image. And now we're building our own image on top of this. Next, we can set the working directory for our app within our container. A container has a file system, and for now we're kind of focusing on the Docker file and the Docker image, but I'll kind of just tell you that a Docker image can be used to instantiate containers, one or more containers. So a Docker file is like the blueprint for a Docker image, and a Docker image is like the blueprint for a container, and the container is actually going to run our code within its own like isolated environment with its own file system. Next, let's copy some of our code into the image. And in this case, we're copying our package and package lock JSON. And I'll explain that a little bit in just a second. But next, we're going to install the dependency, which is important, FFmpeg. And after that, we're going to run npm install. We probably could have put this like up above as well. It doesn't really matter the ordering of these. But of course, we can only run npm install after we have copied over the package JSON. Next, we are going to copy all of the source code, all of it. So when I say source code, I mean like everything that we have here, including like the tsconfig and like the source directory, which just has a single file in our case. And then after that, we are going to expose port 3000, because by default, yes, when this code is running inside of our Docker container, it's going to be running on port 3000, but that port is not necessarily going to be available to us outside of the container unless we explicitly expose it like this. And after that, we are going to run a very simple npm start, just like we're doing locally. The reason why we use command here and we're using run for all of these other commands is because command is only run once. That's kind of like the command that runs when we actually start up a container. Only one of these is allowed. Now, we probably don't need to copy over the node modules when we're building our image, because that's what we're going to be installing anyway. So what we can do, similar to having a git ignore, is we can create a file called a Docker ignore. And inside of that file, we can put node modules, and this will basically act just like a git ignore. And when we're building our image, it will ignore the node modules directory because it's unnecessary because we're just running npm install anyway. Now, one thing I want to quickly mention is that we use Docker to deploy to a production environment. So you might be wondering, why are we using npm start and why didn't we even build the code here? Like, why didn't I run npm build anywhere in this? Because it's a good question. In package.json, we have a build step and a serve step for actually deploying in production environments. And to keep things simple, if you're new to Docker, what I'm about to show you is going to be really confusing. So I'm actually not going to go super in depth into that because it would take a while to explain. But I will say that the article below will kind of go into details on creating a production Docker image. But I'll also say that this basic Docker image will also pretty much work for this entire app if that's what you want to go with. You want to stick with like this simple approach. I'm also going to now copy and paste that more productionized Docker file that again will be linked below and fully explained in the article below. It's about twice as long because it has 2 steps, a build step, a build stage, and then a production stage. And basically this is a lot longer because it's going to actually build the application and serve the files from that directory. And also, this image is going to be slightly smaller because we're actually not including any of the source files in the final image, even though you can kind of see we copied the source files, but that was in stage 1, and stage 1 is not what's going to be reflected in the final image. So that's like the high level explanation here, but I don't want to spend like a ton of time on Docker because it can get kind of complicated for beginners, and the first Docker file I showed you should be sufficient for you anyway. But now let's get into the actual interesting part, and that is the CLI. So Docker has a pretty good CLI, and by that I mean it's not like super complicated. It's pretty intuitive. So the first thing we want to do is within the video processing directory, and why we're within that is because that's where our Docker file is located, as you can see over here. So I'm gonna clear screen again. The first thing we want to do is build an image using this Docker file. But before I even do that, let's show all of the Docker images we currently have. So you can do that with Docker images. Right now, it's a very empty list here. You can see these would be the fields that we would have if we had any images at all. Currently, we do not. So let's go ahead and actually build one. And I'm going to do that like this: Docker build -t, which is for tag, which is what we want to call the image. I'm going to call it video processing service. And we can add a colon for the version. Like we could say 1.0, 1.1, but I'm not going to include that just to keep things simple, but you can feel free to do it if you'd like. Then I'm going to end it with a dot because within the video processing service, that's where the Docker file is. We don't have to like specify Docker file because the name is always going to be the same. It's always going to be called Docker file. So we just have to specify the directory. So running this command, the first time you do it, it's going to be quite slow. It's going to be pulling the node image. It's going to be running all of these steps, but subsequently it might be able to cache a lot of these steps. It will already have pulled this image before, and this image will be saved to your computer. So it's going to take a while. I'll go ahead and fast forward. Okay, now it's done. And I'm going to run clear again, and I'm going to now run Docker images. And you can see we have multiple images actually. One is the video processing service here, and another is the node image, the base image that we actually started with. You can see that this is already pulled and saved to our system. It's node version 18. And now we want to actually run our Docker image that we built, the video processing one specifically. And by the way, I think this none is from the first build stage, which we didn't actually use. Like the second stage, in my case, the production stage, is the one that actually created the video processing service. If you had the first Docker file that I showed you, the more simple one, you probably won't have this entry, and that's perfectly fine. Now, to actually run a Docker image and create like a container, that's what we're going to do. You can either use the image ID or you can use the name, and that's what I'm going to do in my case. So I'm going to run clear, and then I'm going to say Docker run, and we're going to do -p because we're going to do port forwarding. Remember, the port won't necessarily be available on our local system, our host system, so we have to forward that port from the Docker container like this. And I'm also going to do -D. That basically detaches it so that then we can continue to enter commands into this shell. And which Docker image are we running? Well, it's the video processing service. And now I'm going to run that. There we go. It looks like nothing happened, nothing significant happened, but to test it out, I'm going to clear again, and then I'm going to run docker ps. That's kind of like ls for your containers. It's like listing your containers, and you can see we have a single container running. It is the video processing service container. It started 15 seconds ago, and the port is being forwarded properly. And one thing I actually forgot to mention, I really apologize for this, is that in your directory, to actually test this out, you might have had that processed neatcode video. I would delete that video, but I would leave the original video because when we actually run the processing code, we want to reprocess that video and just want to make sure that this code works from within the Docker container. I think if you left that file there, this code would probably overwrite that file, which is perfectly fine. And we would know if an error occurred from like the logs of this, but that's something I would just recommend doing just to double check. Now that we go ahead and test this out, we will see, can we actually convert a video from this Docker container? And actually testing it out is going to be very, very similar to what we did last time. And we can actually pretty much reuse the request that we made last time. That's kind of the benefit of using Thunder Client, in my opinion. Since our container is running on port 3000 again, and the port is being forwarded, we can make the exact same request now. So let's go ahead and run this. Okay, and we got an error, and actually I know exactly why that happened. If you are using the more simple Docker file, it probably didn't happen for you, but remember, in my case, I did not actually copy any of the source files. I only copied the final compiled files into my Docker image, which minimized the size of it. That means we never moved this file into the system. So when we ran this code, it can't find the video, but that's something we can actually easily remedy. And it will also teach us a little bit more about Docker. So I guess it's a win-win. So I'm going to go to the CLI and I'm going to run docker copy, and we're copying a local file, that neatcode video, into our container. And actually, let's get the container name before we even do that. I believe in this case, this is the container name. It's not actually the image name. You could, I believe, use the container ID as well, but I'm just going to use this because it's a little bit more friendly. So now running docker copy, we're going to copy a local file, the neatcode intro video, into this container, beautiful Jang. And in that container, where do we want the file to be located? Well, we want it to be in the same directory that our start command was run, which in our case, I think is going to be the app directory. So I'm going to go ahead and do that. And we're going to call the file neatcodeintro.mov within that directory as well. So let's see if this command works. Yep, hopefully the path is correct. So now let's go ahead and rerun that request. And now the file should actually exist. So let's run it. And yep, perfect. So now the video was actually processed, but there's one problem and you might know what it is. Where's that file? It's not in our local file system because remember, Docker containers have their own file system. But just like how we can copy a file from our host into that container, we can of course copy files out of that container as well. And it's just as easy. We can say docker copy from the container, which was called beautiful Jang. This is exactly why I used that more friendly string. And from that container, we know where that file is going to be. It's going to be within app, and that file is going to be called processed-neatcodeintro.mov. And where do we want to copy it? Let's just copy it into our local current directory. So let's run that. Whoops, I think I probably got the name wrong. Maybe it's called processed. So let's try that. Yep, that one worked. So that command was successful. And let's look at our local file system and scrolling down. Yep, we have that processed video. So I'm just going to assume that the code did run correctly and that this is also going to be 360p. I'm not going to show you the video again because you probably don't care. But this might have been pretty overwhelming because we definitely learned a lot in this video. I promise you that as you continue to practice it and maybe you rewatch this video and you run the commands yourself, maybe even doing it twice or 3 times, this type of stuff will sink in. Now let's just do a little bit of cleanup before we end this video, because running Docker on Linux is not super obvious. If you are running it on Mac OS, you'll probably have like a Docker Hub UI that you can kind of see all the containers that are running. But in our case, we're going to do everything via the CLI. So let's see our running containers. We can see this container is currently running. So let's go ahead and stop this container either with the ID or the name. I'm going to use the ID. So Docker stop this container. Now, if we run Docker PS again, we see there's no containers running. Yeah, that's correct. There aren't any containers running, but there are still some containers that exist. And you'll know that by running Docker PS -all like that. And you can see that this container, it exited 13 seconds ago, but it still exists. We don't need it anymore. So let's go ahead and say Docker remove this container. And there we go. Now we rerun Docker PS-A. There's no containers anymore. You could also remove Docker images if you wanted to. For example, if I wanted to remove this image, I'd take the image ID and then I can run Docker image remove like this. I won't do that, but if you'd like to, it's that easy.